Hello, everyone. Welcome to the presentation of our work, Action Anticipation at a Glimpse, where we study to what extent multimodal cues can replace video-based features for action anticipation. Let's start with the motivation. Most action anticipation methods rely on video sequences, which are computationally expensive and require long temporal aggregation. However, as humans, we can often anticipate actions from a single glimpse. A single moment frequently provides enough context to predict what will happen next. Moreover, multimodal cues such as spatial depth and semantic context can potentially replace explicit temporal reasoning. Based on this intuition, we propose a single-frame multimodal approach for action anticipation. Our main contributions are threefold. First, we introduce a single-frame action anticipation framework that leverages multimodal cues instead of video sequences. Second, we propose AAG, a novel architecture that fuses RGB, depth, and action history through attention-based reasoning. Finally, we demonstrate competitive performance compared to video-based state-of-the-art methods while requiring much lower computational cost. This figure shows an overview of our AAG framework. We start from a single RGB frame. Three modalities are processed in parallel: RGB appearance, depth information, and action history. We then integrate visual cues using cross-attention and combine all modalities through a self-attention transformer encoder. Finally, the fused multimodal representation is used to anticipate the upcoming action. Here, we show the depth processing pipeline. First, instead of relying on noisy depth cameras, we use depth estimation networks, such as Depth Anything V2. Then, we apply depth colorization, which allows us to use standard pre-trained RGB encoders for depth inputs. This provides cleaner and more reliable spatial cues. Next, we incorporate action history to provide semantic temporal context. We study three aspects. First, the ability of vision language models to retrieve past actions under different contextual cues. Second, we analyze different encoding strategies, comparing textual descriptions with alternative representations. Finally, for realistic inference, we use a single-frame action recognizer to populate the action history. We evaluate our approach on three procedural datasets: IKEA ASM, Meccano, and Assembly 101. IKEA ASM and Meccano are evaluated using top 1 accuracy, while Assembly 101 uses mean top K recall. These datasets vary in perspective, complexity, and sequence length. First, we analyze the contribution of each modality. We observe that visual cues provide strong spatial context, but are limited on their own. Action history adds high-level semantic priors, significantly improving anticipation. However, we identify a bottleneck in realistic settings, where recognition errors propagate to anticipation. We also observe a perspective bias, where close-up egocentric views increase blur and weaken depth cues. Next, we compare our method with video-based state-of-the-art approaches. On IKEA ASM, our multimodal single-frame approach achieves competitive and even superior performance. On Meccano, performance is more limited due to challenging egocentric viewpoints. On Assembly 101, results are further constrained by task complexity, with over 1,000 action classes, highlighting when temporal reasoning becomes necessary. We also compare different sources of action history. We find that VLM-based action history retrieval struggles under different prompt strategies and state-of-the-art models. In contrast, adapting our method for single-frame action recognition provides a strong action history representation while being more efficient, as cues from the anticipation setup can be reused. To conclude, single-frame multimodal cues can effectively replace video-based processing in many action anticipation scenarios. Our AAG framework successfully fuses RGB, depth, and semantic history using attention mechanisms. We achieve competitive performance with significantly lower computational cost. However, Complex tasks, challenging viewpoints, and recognition errors still require temporal reasoning. Overall, our work highlights when single-frame anticipation is sufficient and when video remains necessary. Thank you for your attention. Feel free to check our open-source implementation available on GitHub.